First point is already created at a 0,0 location. Next point we are going to create at 100 y distance over here and just say OK. We can see two distinct key points over here at a y height 100. Say line, straight line over here. Now once our modeling with respect to the geometry is over, now cross check our element type. Over here we are having already link 1. Once we are having our element type, now we need to go for meshing. Say mesh tool, cross check our global, all things are assigned with respect to the material number, real constant, set, element type, and then say OK. Now we need to go for the size control. I need to go for the 20 number of element along this particular length. Say number of element divisions 20 and just say OK. After that we need to say mesh it, select that particular line and just say again OK. We can see our plot control, numbering, say element numbers and just say OK. We can see the 20 number of elements assigned on this particular line over here. So once our meshing is over, now we should come out of our preprocessor and just say solution. In the solution we need to check for the analysis type. It is a static case again, but it is a static with respect to the solution control. Again we need to go for the controlling of a solution. According to this particular diagram, we are having an axial loading vertically upward at the top edge. All the degrees of freedom are locked at the bottom one and having a P magnitude of a 10,000 Newton over here. So we are going to calculate for the last displacement. It is a nonlinear analysis. Time at the end of a load step 0, but we must switch on for the automatic time stepping. We are going to divide our 10,000 loading into 20 number of substeps. Now then 10,000 I need to divide it maximum number of substeps as a 1000 and minimum at least must be 1. We need to go for the results output of all quantities, and here we are going to see I need to plot for every substep. Once we are changing these things, now we need to go for the nonlinear solutions. So all things where we are changing are in a basic. Now we need to go for nonlinear over here. Select over here as a nonlinear. Now we need to change for line search, switch it on. What exactly the line search stands for? The line search is nothing but your Newton-Raphson approach to converge the solution. To get a solution we are going to adopt for the Newton-Raphson method, and now we need to go for that particular maximum equilibrium iterations over here as a value. So I am entering here as 1000. So in that ways we need to go for line search on, and to converge our solution according to the Newton-Raphson approach we need to enter for the maximum number of iterations over here. So once we are setting for the basics, and next is we are setting for the nonlinear analysis, and then say OK. We are going to see a plot over here. Once our solution control is over, now we need to go for the defining a load. Say apply structural displacement on the nodes, select on the last node, say OK. We need to lock for all degrees of freedom and just say OK. Next is point load vertically upward, say force on the top node, again say OK. Y directional 10,000 and just say OK. We can see our force value over here, all degrees of freedom are locked. Now we need to go for the nonlinear analysis of this particularly. Say solve for the current load step. Close our status with respect to the given inputs and just say OK. We are going to get our same graph with respect to the cumulative iterations and absolute converge norm according to the given specifications in a solution control, and just close our node, right click, say replot, back to our elemental geometry. Now we can see our general post processor, plot results, deform plus undeform, and just say OK. We are having a maximum deformation over here at the 11.176. So this much of a deformation we are going to get with respect to this particularly. So if I need to go for the time history plot. So we can go for that one. Say time history post processor. In the time history post processor, say add your data DOF solution in the y directional component. Just say OK for the top node. Select that one and again say OK. We are going to add that one displacement over here. Again say a graph plotted for those things. So we can go for the plotting of a graph over here. So in that ways we are going to get that particular solution. Again add, we are having one unknown to solve over here as the reaction supports over here. So reaction forces, structural forces in a y direction. Say structural force in a y component of a force. Say OK. Now we need to select for the bottom node. So plot our elements back over here. At the last node, reaction forces. So select these two parallelly and say plot over here. So we can see our plotting over here with respect to the list of values, time, y directional displacement and a reaction force magnitude over here according to the application of a external loading with respect to the specific locking of degrees of freedom. So these are the ways we need to go for the calculations over here. So we can plot our elements back, check our general post processor, read results, say last set, deform plus undeform and just say OK. We can see the maximum deformation occurred over here in that particular beam. Say plot control, style, size and shape, just sit on over here and just say OK. Now we can see the nodal DOF solution with respect to the y component and say OK, we are going to get a plot with respect to the size and shape of that particular beam over here. So in that ways we need to go for the maximum DOF calculations with respect to the time history plot also. So these are the ways we need to go for the non-linear